portal method, it is applicable where height is less than its width. Okay, height of the multi-story building frame, it is less than its width. Or for low rise structure, portal method is suitable. And the cantilever method, where the height of building is much more than its width. Or we can say for the high rise structure, the cantilever method is generally adopted. Okay, generally where height is greater, then we have to use the cantilever method. But in examination, they will specifically mention, okay, in examination they will mention analyze using portal method or cantilever method. In case of offline examination, conventional, if it is online, then they will ask in between step, what is the shear force for beam, what is the shear force for column, or what is the bending moment, when to apply the portal method, when to apply the cantilever method, like that. Okay, and the cantilever method, it is generally adopted for the high rise structure. And in this particular method, we can analyze the multi-storied building frame if there is a different cross-sectional area. If there is a different change in cross-section is there, if there is a change in cross-section, in that case also, we can use this cantilever method efficiently. Whereas that is one of the drawback of portal method. If there is a change in cross-section, then we can't consider that effect in case of portal method. But here, if columns are having different area of cross-section, that we can consider that effects in this cantilever method. Okay, so these are the basic points of the cantilever method. Now assumptions. So both the methods are based on the basic assumptions. So first two assumptions are common for both the methods, portal method or the cantilever method. First two assumptions are common. Just third assumption is different. In case of portal method, third assumption was horizontal shear of interior column is twice as that of the exterior one. So that third assumption will be different in this cantilever method also. Now tell me, what is the first and second assumption? प्रसाद मस्के सांग, फर्स्ट assumption काय होतं पोर्टल मेथडचं, तेच कॅन्टिलिव्हर मेथडचं पण आहे. What is the first assumption? प्रसाद, roll number 10. First assumption. Sheetal. First assumption.
Point of inflection are located at mid height of each column.
Yes, very good. Point of inflection is located at mid height of each column. Means the bending moment will be 0 at mid height of each column. Good. Second assumption. Nayan. Nayan Jadhav. Second assumption. First, inflection point at mid height of each column. Second assumption. Second assumption कोण सांगेल? आशा सांग. Second assumption. Second assumption is point of inflection is located at mid span of each beam, as that of column it is located at mid height, and for beam it is located at its mid span. Okay, these are the first two common assumptions for both the methods. Mid height of column, mid span of beam, point of inflection will be there. Third assumption, it will be different. बघा वाचत आहे काय आहे. Third assumption, the axial forces in columns are directly proportional to their distances from centroidal vertical axis of frame. समजते काय बघा. Axial forces in columns are directly proportional to their distances from centroidal axis of the frame. Means what? In case of column, so this third assumption, it is there for the column. Now that assumption we will discuss. काय म्हणलेलं आहे? Axial force in a column. Axial force in a column are directly proportional to their centroidal distance about the vertical axis of the frame. Now in case of column, if this is the column, okay, this is the inflection point. So at inflection point, we are getting two forces. This will be H, this will be V. Now out of these two forces, which force will be the axial force? Which force will be the axial force? आता आपल्याला हे तर समजलं पाहिजे ऍक्सेल फोर्स कोणता आहे कॉलम मध्ये, तरच पुढचं अजम्पशन येईल. हा सांग धनराज.
V vertical.
Yes, vertical force in a column will be the axial force, the force which is acting along the height, or we can say length of that particular member. That will be the axial force. In case of beam, the horizontal force will be the axial force. Beam मध्ये काय असेल, horizontal force हा axial force असेल. Okay, means here what we have to do, or what assumption is saying, so this axial force, this V axial force for all the columns, it is directly proportional to the centroidal distances. म्हणजे काय, that we will discuss now. Suppose this is the frame, ही आहे frame. So there are three columns, and suppose I have taken the section here at mid height of bottom story. I will consider initially, suppose, for simple understanding, or else I will draw story like this. Okay, mid height of each column. If I take the section, then I will get two forces. One is vertical, suppose this is vertical, this is vertical. Okay, this is vertical direction, you can assume downward, downward, upward, upward, anything. Okay, at each mid height point there will be two forces. One is vertical, another is horizontal. One is vertical, another is horizontal. Vertical, horizontal. Now इथं असं करायचं नाही, इथं H असेल, इथं 2H असेल, असं करायचं नाही. का करायचं नाही? H2H चा फंडा इथे येणार नाही, because that is the assumption in the portal method. That is the assumption in the portal method. Here the assumption is different. So here unknown will be that horizontal forces. Here unknown will be these horizontal forces that we have to find out. Suppose for this particular frame, the centroidal axis, we have to find out the CG. So what is the step number one? We have to find out the centroid, means we have to find out the y bar. Sorry, we have to find out the x bar. CG distance we have to find out from this left column. So we will consider the frame of reference. This will be y-axis. Okay, and this will be our x-axis. So we have to find out this x bar distance. That we have to find out. That formula also we know. Okay, so that x bar is what? Summation ax divided by summation n. That we'll discuss in detail. Okay, firstly we have to find out the centroid. Then, so suppose this distance is x, or we will consider this axial force to the centroidal distance is x, this second axial force to the centroidal distance is y, and third axial force to the centroidal distance is suppose z. So what third assumption says? Third assumption काय आहे? So these axial forces in column x, y, z, are directly proportional to the distance from the centroidal axis. Means x, so that axial forces P1, suppose this will be, I will say 1, 2, 3. Okay, 1, 2, 3. So axial force 1, 2 and 3 are the proportionate with the distances from the centroidal axis. So we can say axial force 1 divided by the centroidal distance x from the centroidal axis is equal to axial force 2 is proportional to the distance from the centroidal axis. Suppose that will be y. Axial force 3, it is proportional to the distance from the centroidal axis z. So this proportion will be constant. This is our third assumption. Axial force is a vertical force. These are the vertical forces, or the axial forces are proportional to the distance from the centroidal axis. So 1 depends on this x, 2 depends on the y, and z, 3 depends on the z. So that proportion 1 by x is equal to 2 by y is equal to 3 by z. This proportional is going to remain the constant. This is our third assumption. पोर्टल मेथड मध्ये डायरेक्ट तुम्हाला एच भेटत होता. होरिझॉन्टल शेअर विल बी ट्वाइस as that of the exterior. Here we are getting the proportion, we are getting the proportion for the axial force. म्हणजे at a inflection point we are getting the vertical forces. हे झालं proportion, we have got one equation. Secondly, get the summation of moment at this particular right side column, then you will get that 1 2 3 axial forces. हे तुम्हाला व्हॅल्यू भेटतील नंतर. ओके, means if you take the section here in cantilever method, again three forces are unknown. Out of three now, two will be vertical, one will be horizontal. That is the change in cantilever method. At a joint, three forces will be unknown. Out of three, two will be vertical, one will be horizontal. Okay, so this is third assumption. So again we will discuss in detail steps to follow, and we will see the numerical in the next session. Okay, so I think next session it is at 2:15. So we'll meet at 2:15 once again with the same link. Thank you.